Hello everyone, my name is Dat Nguyen and today I gonna bring you my topic for final exam Chem 01. So today I gonna go through all the topics on my hand over here, include the main thing I talk about electron affinities, and after that I go through a little bit about characteristics of metallic group 1A and group 7A. Okay, so first of all, I want you to know what is electron affinities. So electron affinities is an atoms or ion is the energy change associated with the gaining of an electron by the atoms in the gaseous state. So when atoms or ions gain electron, it releases the energy. The attraction between the nucleus of an atom and the incoming electron will release the energy. So I give you an example. Chlorine in gas state, when it gains one electron, it's gonna become the chlorine -1, and the electron affinities, the energy released out, gonna be -349 kilojoule per mole. Okay, so why we need to know about this? The electron affinities. Electron affinities is a measure of how easily an atom will accept an additional electron. So we can know how active of an atom or ion. Now we go through the electron affinities charts over here in every group. As we know, when we move down a column, right over here, the electron entering the orbital less easier because it had a higher principal quantum numbers of electrons. So based on the periodic properties we learned so far, so would you expect more energy to be released by such as sodium or chlorine over here? Okay, so you see here, as I move down for each column, for each family or each group, see that the energies, the electron affinities energies is lesser. So why it happened like that? Because like I said before, when you go down to the group, the quantum electron is higher, so it less ability to gain more electron. So why it happened like that? Because when you go down from the columns, like I said, the quantum electron increasing, so it's more difficult to gain in electron. But when you go to the row, the number of electrons is different, 1, 2, 3 electrons. It tends to gain more electron, it gets more energy. The period table over here, the atoms follow the columns. The atom's radius decrease while ionization energy increase. And when ionization energy increase, as a result, electron affinity increase. In contrast, it's gonna different with the columns. So the atomic radius of the columns gonna increase, and it's gonna lead into the ionization energy decrease. When ionization energy decrease, as a result, it's gonna make electron affinities decrease. Okay, so based on the periodic table properties we learned so far, would you expect more energy to be released by the sodium or chlorine when an electron is gained? You see, over here the sodium had the electron configuration and the outermost electron configuration is 3s1, and the chlorine outermost electron configurations is 3s2, 3p5. So over here, the outermost electron chlorine experience is higher than the outermost electron in sodium, right? Because when adding electron to the chlorines give a noble gas configuration, and adding electron to the sodium it does not. So that means the chlorine or halogen group 7 gonna be has more, that's the more negative electron affinities. Alright, but however, we have an exception occurs at the group 5. The element of group 5 have the outermost electron configuration is what? N2 and P3 here. But in the group, in the orbital P, you see that the electron spread out of each block. So when the electron is gain electron, it added one more electron in these configurations. It must pair with another electron, and this pair is repulsions between two electrons occupy the same orbitals, cause the electron affinity to be more positive. That's why in the period table you see the group 5, the theory is different with another group. So what is metallic character is character of the metal. We look at the period table. As we move to the row from the left to the right, the metallic property decrease, and we move down in the column, the metallic property increase. As we know, metals are good conductors of heat and electricity. They are often shiny and they tend to lose electrons in chemical reaction. And non-metal and usually form in the right side of period tables. In contrast, they tend to gain electrons in chemical reaction. So as we move down from the row or move down from the columns, the metallic character gonna change it. Okay, so I go through the alkali metal. It means group 1. Alkali metals, the first group include lithium, sodium, potassium, rubidium, cesium, and francium. Has the atomic number 3, 11, 19, 37, 55, 87 is increasing, and as well as the atomic weight increasing as well. So as we move down to the column, the increasing of mass due to addition proton and neutron increase. So because of low ionization energy, the alkali metals are excellent reducing agent. They are readily oxidized, losing electron to other substances to become stabilized. Since the ionization energy decreases as we move down the column, the relative reactivities of the alkaline metal tend to increase. The lower ionization energy of an alkali metal, the greater tendencies it will have to lose its electron and more reactive is it. For example, over here I have the alkali group reacting with water. The reaction becomes progressively more vigorous as we move down the group. Lithium, sodium, and potassium, because it tends to lose electron faster. Okay, next I'm gonna talk about the halogen group 7. Include fluorine, iodide, bromide, chloride, all of the halogens are powerful oxidizing agents. They are readily reduce or gain electron from other substances in reaction. They just want to take one more electron to get the noble gas state. Fluorines is the most powerful oxidizing agents of the group, reacting with almost everything, including the heavier noble gases, and iodide is the least. And at the group 7 halogens, it can react with first a hydrogens to form hydrogen halogen, like between any compounds include two non-metal. It's gonna be contain the covalent bond, and halogens it combined with another metal, it's gonna form up the ionic bond. And also halogen and halogen, it can react to other to form inter-halogen compound. Also is the covalent bond. Alright, so you see that here is a symbol of sodium metal and chlorine gas. It's gonna react together, it's gonna form sodium chloride. This reaction gonna emit heat and spark because it very strong metal and strong non-metal react together. In conclusion, so I go through with you what is the electron affinities is. That's the what ability to atom or ion want to gain electron and release energy. Another one is I talk about the metallic characteristics. I talk about group 1, the alkali group, is very strongest metal in the group. It tends to give out electron to be the strongest metal. The second group, halogens, is non-metal, the strongest non-metal. They tend to gain electron, they get the highest energy, affinity energy, that tend to give out one electron to be stabilized. Alright, that's conclusion everything I want to talk to you. So, if you had any question, contact me back, but if not, like, have a good day first. Bye bye.